Let's look now at municipal water treatment in the well houses. The two primary chemicals that we're dealing with for the Southwest water system, the Southeast water system, and the Norwood Knolls water system are polyphosphate and chlorine. Southwest water system is bound north to south by Gunn, Silver Bell, and Dutton, and then west to east by Kern to Gallagher. A 1,000,000-gallon water storage tank and booster station are planned for this water system starting in 2024. Design should be complete in 2024 and out for bid, and then construction will either start at the end of 2024 or a beginning of 2025 and then go all the way through 2026. The advantages of the new tank are redundancy in the water system, consistent pressures during peak summer demands, and then improved fire protection. In the Southeast water system, we have two pressure districts. This is the Northern Pressure District. It's important to note that this district has not had chlorine and phosphate previously, but it is going to start being added in spring of 2024. You may notice a slight change in your water quality parameters because of this. The major roads here are Gunn and Rochester down to the southern part of Guardian Angel Cemetery. Here also the Southern Pressure District, chlorine is added now and polyphosphate, and that goes all the way down to Meade. A 500,000-gallon water storage tank was installed there and will be put into use starting in 2024 as well. That will also have improved fire protection and pressures. Here in Norwood Knolls, near Buell and Haddon, and then Inwood, you can see that water system there. Polyphosphate and actually, I'll go back. Polyphosphate and orthophosphate are added there. Orthophosphate is in the very similar family and is used for corrosion protection. The Twin Lakes water system also uses orthophosphate for corrosion protection. As of spring of 2024, all 7 water systems, all pressure districts in all 7 water systems in Oakland Township will be using chlorine for disinfection. So going back to that municipal water treatment, let's see how these chemicals work. So liquid chlorine in the form of sodium hypochlorite is used. Chlorine is added to prevent harmful bacteria from growing in the water mains and in your home. Chlorine is an oxidant. It's a reactive molecule that breaks down other molecules. Chlorination of drinking water is widely regarded as one of the most important public health advances of the past 100 years. However, chlorine turns soluble iron into rust, unless you add polyphosphate. Polyphosphate traps or sequesters that soluble iron to limit the amount that changes into rust. Here we're going back to the well house, so let's take a look at how that process works. Water from the left is coming from the well, from the ground, and then on the right it goes out to the water mains. So looking at this, again, it's important to note that the North District of the Southeast water system will start treating with chlorine and polyphosphate in spring of 24. This was not extremely relevant to them before, but it is now. So from the ground, we have soluble iron that comes in through the raw water main, and then we dose with polyphosphate. That polyphosphate then kind of sequesters that soluble iron, preventing it from reacting with other things such as the chlorine. Chlorine is that oxidizer, it goes in. Now you'll note that the chlorine kind of bounces off in the diagram. It bounces off the sequestered iron. There may be some insoluble iron that does not react with the polyphosphate. That's that little yellow guy there. And that one will react with the chlorine to turn it into rust and goes into the water mains. Does polyphosphate work forever? No, it slowly degrades. And when it degrades, it releases that soluble iron that was trapped. So since water is chlorine, that soluble iron will quickly change to rust. So it could be a few minutes or up to a few days for water to reach your home after that polyphosphate is added. Now, after about 10 days, up to 25% of that polyphosphate can degrade and release the soluble iron, which will immediately turn into rust, as you can see there. More questions. Polyphosphate is added to our water, so why do we still have so much rust? Polyphosphate can trap some of that soluble iron, but not all of it. Without polyphosphate, your iron problem would actually be much worse than it is. Now, can we add more polyphosphate to trap all of the soluble iron? No, unfortunately. Adding more polyphosphate can actually reduce the effectiveness overall. An iron treatment system would be needed at the water source to improve municipal iron removal if you guys wanted to go that route.